Hello and welcome to today's Decision Fest panel. Our topic today is Lessons Lived and Learned, Project Success and Failure in Decision Science. My name is Haley, and I'm part of the Nextmv team supporting today's event, which features these four panelists, Carolyn and Ryan from Nextmv, Karla from GMU, and Doug from Walmart. I'm going to let them introduce themselves in more detail here in just a moment, but first, I'd like to cover a few notes. Today's session is meant to incorporate your comments and questions, which you can share in the chat off to the side. Just be mindful of that host and panelists versus everyone toggle to make sure that your message goes to the right audience. There's also a Q&A feature at the bottom of your screen that you can use. A few of us from Nextmv will be monitoring the chatter today and are happy to help surface any questions that come to the panel throughout the session. We will also have some time for dedicated Q&A toward the end. So our time is a little bit flexible today. We may end at the half hour. We've got a little bit of buffer room on the end for bonus conversation. So if you're not able to stay for the whole time, don't worry. We are recording today's session and we'll make sure to share that with you afterwards. So with that, I'm going to hand it over to the panel to dive right in. I'm really looking forward to this one. Carolyn, I'll have you kick us off and take it away.
Sounds good. Thanks, Haley. And I'm super excited to have everyone here today. And thanks to Karla and Doug for joining us. My name is Carolyn. I'm the CEO at Nextmv, and my background is in systems engineering. I've spent a lot of my career working on modeling and simulation for both the Navy at Lockheed Martin and then in meal delivery logistics, where I met Ryan. So I'll let Ryan go next, and then we'll do some intros all around.
Hi, everyone. I'm Ryan O'Neill, CTO and also co-founder here at Nextmv. My background is in software engineering first and then operations research in grad school. Karla was actually my advisor. So I'm always happy to have a conversation with her about things that are going on. And yeah, I live in Maine and it's cold here and snowy. Let's go on to you, Karla, next.
Hi, I'm Karla Hoffman. I have been a professor at George Mason University for many years. Before that, I worked at the National Institute of Standards. There, I did consulting to government agencies who didn't have large OR departments. So problems just sort of came into us. Somebody knew what the problem was. Then at George Mason, I continued to do a variety of consulting to both government agencies and the telecom, transportation, military, um, industry partners. I'll leave it at that. You'll hear more.
Sounds good. Doug, how about you go next?
Thank you for having me today, Carolyn. Really appreciate the opportunity to be here. I've been with Walmart for the last 6 years in Walmart Global Tech in applied AI, and I focused on supply chain optimization, end-to-end fulfillment, so first, middle, and last mile. I recently just took a new job running AI for real estate, manufacturing, and energy. I spent the first 10 years of my career in the airline business, so American Airlines, the original ops research group that became American Airlines Decision Technologies and Sabre Airline Solutions. So started my career in OR, then moved into online commerce. I was the original CTO at Travelocity. And then I spent about 10 years doing a variety of startup companies in e-commerce and software. And then I got back into analytics in 2014 as director of enterprise data and analytics at Southwest Airlines and spent 5 years there. And cumulatively throughout my career, by the end of this fiscal year, my teams will have delivered about $4 billion in measurable economic value with analytics, data science, and AI.
Awesome. Yeah, and I love the focus that both of you have on kind of the success and failure of projects and kind of how to quantify that. So maybe to kick us off, and the context here is we're trying to understand as practitioners and as business leaders how we can leverage decision and data science effectively. And so I think everyone loves a good failure story. So maybe we can both start with a project that you saw fail and maybe some of the things you notice about why. So Karla, maybe I'll have you go first, and then Doug, you can go second, and would love to hear kind of some questions along the way.
Okay, well, as I said, I started at the National Institute of Standards and had a project with a government agency, and the client had come to us. They knew what they wanted. They didn't have some of the data they needed. So there were lots of interesting problems, but we listened to our client and we thought we were successful. I think there are two interesting stories associated with that. One is it was a complicated problem, so it had simulation and it had data analysis and it had some optimization and some queuing theory in it. We tried to publish a paper that described the whole thing, and everybody said you need more than one paper. And we allowed that, and that means the total story was never really obviously described for a practitioner. So that was failure number one. Failure number two was the IRS. It was really happy with our results and asked us to do another project. And we went out to some of the offices to see how they were using our prior project, only to discover they weren't using it at all because the offices had no idea even how to log on to get to the software. This was a failure much greater than I had. I mean, we got the papers published. The client was thrilled, and then we learned nobody was using it. So our second project related to using PCs in offices so that all they had to do was log on to their own PC and get the job done. This was at the beginning of the use of PCs. We had to do all of the graphics to get everything right. We went out to our first user, which was a division director, which is somebody responsible for the entire state. And this person said, I hate it. And that was not exactly what I wanted as a response. And I learned the reason that she hated it was because of the colors. And that's when I realized we had to go to lots of different offices and learn how they wanted to see the results. This was really pretty early in my consulting life, and it taught me a variety of lessons, namely, talk to the people who are going to use the software rather than the people, not only the people who are paying for this, and be willing to change lots of things over time. So I'll stop there.
No, I really like that. I think, Doug, I was reading your book, The Why Data Science Projects Fail, and one of the things in there talks a little bit about like if you hand over kind of like a black box solution, right? Like what happens? So maybe you can kind of expand upon that, or if you have a different example, that's fine too. But talking about one of those failure modes for decision and data science products.
Sure. So it's rare occasion that you get to fail on a project and then 20 years later take on the same project again and succeed. So
But that's the best. The get to rewrite history.
I'm going to tie my success and my failure together. But to start with the failure, it's
Yeah.
not all that different from Karla, at least in terms of the things that really made it unsuccessful. It was very early in my career, and I was right out of graduate school a couple of years. And I thought that you looked at a problem, you wrote down the math, you coded it, and you handed it to the customer and said, "Here you go." And that didn't work. The domain was at American Airlines, and it's airline irregular operations recovery. So everybody's been stranded in a snowstorm or a thunderstorm, or when the whole airline is, gone kaput for a variety of reasons. It could be, and airlines have to put those schedules back together in real time, like a puzzle. The aircraft, the passengers, the crew, the cargo, and you have to abide by a variety of rules. Things like, you can't land at Orange County after 10 o'clock or take off due to noise abatement. There's all these rules about how airlines operate, right? And airports operate. So we literally wrote down the math, me and a very smart PhD that I was working with, and our customer had no interest in anything that we were doing. The data was scattered everywhere, from mainframes to PCs to charts on the wall. It wasn't very conducive to building a model, testing it, validating it, when it was very, because the users were convinced there was no way we were ever going to be able to get a computer to solve this very, very complex problem. And we failed. We worked on it for 6 months and we never got any traction. And we went back to the well several times trying to get different stakeholders to engage and work with us. And it really taught me how important that business domain expert involvement and engagement, we call them champions. Nothing
Yep.
ever gets done without a champion. And the math and the data and the technology, as important as that is, it's really quite secondary to that whole process of change management, right? Where you're completely revolutionizing the way people do things. It's intimidating, it's scary. And when I get to the success part, we'll see how we turn that around 180 degrees and made it into a huge success. But it was definitely an early career failure on my part.
Yeah, I think Ryan, you and I saw the same thing, right? At some of our prior work, like especially when we were at Zoomer,
Yep.
I think one of the coolest things that we had in that experience, right, was like sitting next to operators. I remember you talking about that a little bit.
Yeah, we would get a lot of direct feedback, and there was sort of like nothing like being right next to the dispatcher, right, when they were looking at routes and saying like, oh, this is why I don't like this one. Um, it was feedback that you'd never get through any other channel.
Yeah, for sure. Doug, maybe if you can now flip it around and start talking about your success
Sure.
from the same project. I think that's like a nice like segue into that since it's a similar problem.
Absolutely. Well, it's the same problem, but now fast forward to 2008 at Southwest Airlines. And I didn't even get to Southwest Airlines until 2014. So they had started working on solving this problem. A gentleman named Dr. Mark Song, who was an Edelman Prize winner when he was at Continental. He solved the crew real-time scheduling problem, won an Edelman Prize for that. Brilliant mathematician, OR guru. The first problem was they didn't have the data. So once again, he wrote down a beautiful formulation, a multi-commodity network flow problem with a lot of side constraints, very hard problem to solve. They worked on getting the data. Then they had to get real-time data. Then they had to get literally cached data where you could literally hit a button and download the current state of the airline. Those systems didn't even exist.
Yeah.
Those
Yep.
systems were all being built. So when I showed up in 2014, they had been working on this for 6 years. And the key to success was we literally put four extraordinarily talented OR PhDs led by Mark in a room with two domain experts, one with 30 years of experience, a supervisor of dispatch that knew everything there was about dispatching aircraft and managing major airline disruptions, and a more junior team member that was very tech savvy. And those folks literally sat in a room for a couple of years. And on my tenure, on my watch, I got there in 2014. They were about ready to put this into production. And I said, well, have we tested it on live data? Have we tested all the data pipelines? Have we tested how the models go? And none of that really had been done. And I said, I think we need to back up. And not only did we need to back up, it took another year of data refinement, model validation. And we actually, to conquer the change management curve, we ran tests. We called them contests, beat the model. And
Yep.
the humans were winning 50% of the time, and we were winning 50%. We just kept enhancing the model and climbed that S curve, learning curve, until the model couldn't be beaten. And not only could it not be beaten, it was solving major airline disruptions to optimality in about 30 minutes. And it used to take humans 6 years to do that. That
Yep.
system won the Agafor's Best Operations Application Award a few years ago. I thought it probably could qualify for an Edelman, but we never got around to doing the paperwork on that. It had a significant impact on reducing the number of canceled flights, reducing the number of displaced passengers, and increasing on-time performance in winter storms by a factor of 2 or 3. So it was a significant improvement. And same project 20 years later, better people, better data, better engagement from the users.
Yeah, I think that's huge. And I'm guessing, Karla, that your success story might have some similar themes to it, but I'll let you go next.
So back to the failure and learning from that failure that you really needed processes in place that talk to the user and how that user made decisions. So we did end up having this PC package, and actually, if you really, it was a bunch of PC packages, but the parameters basically made it one, and users learned how to do that. The proof of success of that was that 10 years later, I got this call saying, we can't get rid of these computers and we have to get rid of these computers, but it has a math code processing chip and we don't know where to find these new computers with math code processing chips. To which I said, all computers have math code processing chips. But isn't it time to relook at the problem and see how it can be improved? But I also want to say that probably my biggest success was with the Federal Communication and their auction work. And like Doug, this was a 6 month gig. You were supposed to be in there, give them the software and get out. And we listened and we created a team that became what was called the optimization team, but should have been called a data science team. We listened and we found what the problems that the FCC were having and tried to help them, give them decision tools to solve them. And 20 years later, there was this auction that brought in $20 billion. But the work involved in that was similar to what Doug described. You had to have everything tested to just an extraordinary extent so that there was no possibility that during this auction something would go down, something would go wrong, a bidder would bid incorrectly, all of the little details and the change management associated with getting systems like that in place, as well as talking to economists and lawyers and a variety of telecommunication people. You had to talk to their language, not my language. So I
Yeah.
think that's my biggest lesson learned.
Yeah, for sure. I think it's always interesting and like in our space, like especially with decision models, they're impacting real world operations, right? So you really do end up having a variety of different teams and stakeholders in the process, right? Like everyone from your IT team all the way up to like possibly business executives if it's a big enough impact, like both of the systems that you both talked about. Those are millions, if not billions, of year of impact, right? So how do you kind of get people kind of engaged in that process, and how do you try to start to break down some of those silos? Like, what comes first? Do you talk about value first, or do you talk about do you kind of put something in front of people, or kind of walk us through a little bit of that process of like of what made those projects a lot more successful? It sounds like they were highly iterative.
I'll go first, but it'll be short. I think you find out for every person in that room that you're talking to, you find out what their issues are. I don't think you walk in with a prototype and say, look how great I am. I say, here's a possible way of looking at that problem. Am I wrong? What is your life as it relates to this problem? And how do we make any tools help you with your problem?
So just to build on that, I can't do a session like this without channeling our friend Gene Woolsey, who did a lot of consulting work in practice. And two things that he talked about when he came to talk to our group at American Airlines that stuck with me was number one, if you try and tell other people how to do their job better with math and computers without understanding everything about it that they do today, you're a fraud. And that's a really strong word, but that really hit me and it stuck with me. And the other one was a manager would rather live with a problem that they can't solve than implement a solution that they can't understand. And in the example that I gave, I failed on both of those, right? Where on the back end, when we succeeded, we went to great lengths to understand exactly how an airline recovers from irregular operations and the data that gets collected, the decisions that have to get made, how to model those decisions, and more importantly, how people are going to use the system, right? So the human factor of all this, I would say, is the absolute most important part. The math is necessary, the technology is necessary, just but not sufficient to get the job done. And if you're missing or shorting the human factor, the change management factor, the engagement factor, learning, exactly how this works in the real world and understanding the business problem and the underlying business process, if you don't do that, everything else is just a waste of time and you're really headed down a rocky road to failure. So
Yeah. I mean, Ryan, what is your favorite phrase about kind of getting models live?
Yeah, the if it's not in production, it has no value thing.
Yep.
Yep.
Yep. Yeah, so I feel like the blockers to getting
Yeah.
into production, we've kind of talked about some of those like with a few of the other sessions as part of Decision Fest, but getting things in front of users quickly, it sounds like that was a key piece for both of your projects, right? Like give people something to react to as you're learning their process, right? Like I think like coming in with that humility for saying like, hey, like I started to model this, like can you give me some feedback? About the structure, or about the input or output, right, is always a nice like kind of way to start the process. I'm curious, like, have you seen over the course of your careers, like where these projects are successful? Like, what happens within those orgs? Like, do they start taking on more like data and decision science projects and AI projects? Do those people kind of level up within the organization and tackle new issues? Like, how have you seen that kind of transform businesses?
Carla?
Yeah, I would say that the answer, at least my experience has been yes, they do. As I said, at the FCC, the term optimization is probably a misused term, but it means that they believe that there is a team that will at least listen to their problem, sometimes say, we're not the experts, but we're going to find you the experts, and then learn a lot. I mean, let me say that being in this consulting space is great fun because you are always learning, and people are always surprising you with their depth of understanding and the complexity of the problems they have to handle. And if you are really curious, which is probably one of the most important characteristics you need to be in this field, you get to learn an awful lot. And then people begin to trust you because you're not just hyping technology.
Yep.
I would just build on that by saying, first, it's better to be lucky than smart. And I was very lucky that I came out of grad school in '87 and was hired by American Airlines Ops Research, working for Tom Cook. And uh, it was 1987. There were 40 people in that group. I was the 40th person, and they were just coming off of the success of revenue management, which Barry Smith and Tom invented from scratch for the airline business. And Bob Crandall, the CEO at that time, was a Wharton MBA, not a mathematician, but a brilliant business person. And I think the smartest thing that he and Tom did was they said, gee, Tom, if you can have this kind of impact, $1 billion a year in revenue, incremental revenue in revenue management, I wonder what we could do in all the other departments in American Airlines. And he literally took a pro rata share of each department's budget and gave it to Tom And I'm talking maintenance and engineering, food and beverage, flight scheduling, crew scheduling, you name it. Every single department got a taste of what OR could do for them. And the
Yep.
result, fast forward 5 years later, is AADT, Sabre Decision Technologies with 500 people. So we grew an order of magnitude, over an order of magnitude, in the 5 years that I was there, and then merged with Sabre, and the rest is history. But I've seen the same thing happen when I was at Southwest. I inherited an OR group of 11 people. It was 22 when I moved on to take over data and brought that with me. We would have success in crew scheduling, and then other people would hear about that. And next thing you know, the fuel department is showing up saying we need help with fuel supply chain. And then when they heard that, the liquor department is showing up saying, well, jet fuel or Jack Daniels, it's just another commodity. Can we use that same tool? And we did. We used exactly the same supply chain management tool that we use for jet fuel to forecast and optimize liquor inventory. So the answer to your question is, if you do it right, and as Karla said, you build that trust and you build that reputation. Same thing happened for me at Walmart. I started with 4 people and I had 20 by the time I got moved to somewhere else. And we started in one little area and then just kept growing our little patch as other people came to us and had other problems that they wanted us to solve. And that's how we delivered that 2 billion in value over 6 years since I've been at Walmart, for 20 people, less than 20 people on average, to do that. So I think there's definitely growth potential if you get some early successes. Everybody wants a piece of that pie.
Yeah.
Groups that are in like last mile, on demand last mile, that do it well. They seem to keep getting new problems to solve. So they start with routing, and then they have scheduling, and then they have, incentives and workforce management and so on and so forth.
All those things you just said, either my boss or my old team are doing.
Yeah.
Last mile delivery at Walmart. Incentives in particular, how to incentivize drivers. So absolutely.
Yeah. Yeah. And I think that's interesting, right? It's just like it kind of grows from there. But it seems like the key there is talking about the value very tangibly. So like both of you have mentioned like dollar values. I think this is like something maybe to kind of double click on, because oftentimes I hear practitioners talking about like the objective function being better, right? Or the improvement in like the time to optimality or things like that, right? And they're talking about those metrics, which I think are important, don't get me wrong. But how do you all see like the difference between like that type of language and talking with business users, right? I think like sometimes we have a gap there. How do you think we can have more impact at a larger number of organizations, and like what does that look like in terms of building that value proposition?
Well, I have two different perspectives on this. One says if you're talking to the CFO, you ought to be talking in the language of finance and economics. And one of my real successes was with a telecommunications company, and it was an optimization. How do you spend a lot of money? A lot of new technology was being expensed, and the question was, where should you be putting all of this new technology? And we did this natural economic model. And there was a surprise because the budget, they gave us a budget and we stuck to the budget. And then we increased the budget just a little to see what would happen, and saw a very large rate of return and said, why aren't you borrowing money and doing more? Now, if you're talking to the CFO, that works really well. Of course, we were also explained that the stock market had never seen this telecommunication company borrow money. So they couldn't borrow as much as they might have wanted to economically. But the other part is, I think in a lot of analytics and OR projects, it's not even the ROI that you should necessarily be worrying about. It's making their decisions better and easier, easier to implement, easier to understand, less risk. And if you walk into projects with that as your argument, it's probably a lot easier than worrying about the bottom line. The bottom line will take care of itself. So there's sort of Depends upon who you're working for.
Yeah, so it sounds like it maybe depends on your audience, and I think you have a bunch on different audiences in your book, Doug. So I know you have some thoughts and comments there. So I'll let you go next.
Sure. I wrote an article that ended up in the Art of Data Science book called "My MBA Made Me a Better Data Scientist." I went back at 40 and got an executive MBA and learned all about, as Carl said, finance and marketing and strategy, and that was extremely helpful. And the most important thing about that whole concept was I said in the article that people ask me, where do we start doing OR or data science or AI? And I said, with the annual report and the financial statements. And people usually kind of then cock their head and squint their eyes and go, what? And I was like, well, the annual report tells you what business you're in and what the company's strategy is. And if you read close enough and long enough, all the challenges that the company is facing, right? High inventory, low sales, whatever, slower delivery times. And then the income statement will tell you exactly where your cost issues are. So if you think about an airline, let's take an airline with $20 billion in revenue. Uh, 45% of that gets eaten up with crew costs right off the top, 9 billion, and then 6 billion for fuel. So 15 billion is eaten up in the first two lines on the income statement, in terms of the two big cost categories. And our CIO asked me at Southwest Airlines, how do you know that our crew schedule optimizer is really saving us money? And I had Rusty Burlingame, my guru in crew scheduling. I said, Rusty, let's run an experiment. Let's take your crew schedule optimizer and turn the dial all the way down to zero in terms of its optimization capability so that it will just generate a feasible crew schedule.
Like a greedy solution, basically. Yeah.
It works, right? The schedule will work. And then turn the optimization dial up to 11, and that's the max, and see what happens. And the difference in the cost of the two schedules was $100 million a year. And that answered the question. And that was 100 million every single year on every single crew schedule. So those are terms that the crew department can understand because they have to crew the schedule at minimum cost and still be operationally feasible. The CFO is happy, as Carl said, CEO is happy, and frankly, the CIO now got it and said, okay, now I really understand the quantitative business impact and economic value that these things create. And I think that gets everybody on the same page. It's
Yeah.
literally the bottom line of why we do this. Now, there are lots of other metrics, customer sat, market share that you can optimize against, but there's nothing like good old-fashioned cost and revenue, and at the end of the day, profit.
Yeah. Well, and I think like implicitly you kind of touched on, Carla, what you mentioned was being able to explain the decisions, right? Like I think there's going from manual like operations where people are doing the planning, you're highly dependent on that labor force, right? That has that knowledge over time, A, staying in their position, right? And B, right, somehow documenting how they're making those decisions, right? Or having kind of like an audit trail or things like that, right? So like that explainability and like auditability, right, kind of ties into that risk profile and also ultimately the bottom line as well. But yeah, I think I'm curious, like, so maybe switching gears a little bit. So we kind of talked about like a lot of the business aspects of decision science and making it successful. I know there's definitely some IT aspects too. And Carla, I think you touched on this a little bit with like, even just like the math coprocessors and things. I think in today's industries, right, they're looking at, cloud infrastructure and kind of managing those pieces. How have you both seen kind of like interaction with like IT departments and software teams be impactful, right, to getting solutions live and successful?
Well, the more the team can do to take the work away from an IT department that has a lot of other things that they have to worry about would be great. But you also need to worry about long term. Who is going to be responsible for the IT, whether it's just getting licenses for the software or making sure that the costs in the cloud are reasonable to making sure that the data continues to be linked properly when the data is changing over time for reasons completely separate from the project. I mean, these are hard things. I will say what my students would consider the fun part of an operations research project is, I would say, I used to say 10%. I'm beginning to think it might be 5% now. That it's everything outside of it, from how you get the change to take place to how you maintain and assure that as the company is moving forward, the team responsible for maintaining this project is aware of what is happening throughout the corporation.
You know, I would say that I'm old enough now to have lived through many cycles of compute, everything from mainframes to mini computers to PCs, now to cloud. And the increase in compute power is amazing. It's happened just in my 40-year career. And the testament to that is that combined with like auto ML tools, where you can literally give all your Y and X's to our own homegrown forecasting as a service platform that we built at Walmart, that my team built. I did not build it. And you know, I asked my team, how long does it take to build a good predictive time series model or XGBoost or whatever, you know? And they're like, an afternoon, you know, given once I've got the data. So that it might take 3 months to get the data, 1, 2, 3 months. But once you got the data, the modeling part of this is really easy. And like Karla said, it's the fun part, right? But even the coding has been reduced to a minimum, that you can come up with the very best model or ensemble of models in an afternoon, let's say at the outside a week, if you really need to experiment, right, to get good predictive accuracy. MIT produced a study not too long ago that validated the number that we put in our book, Why Data Science Projects Fail, that moving from Jupyter Notebook or the cloud instance of a model to production is 2 orders of magnitude more time consuming, more expensive than it is to build a model in the cloud. So 100 times, because that factors in everything that Karla said, building in data pipelines, building in automatic refit or detecting data drift or model drift, and automatically refitting the models, which we do that all the time now. And we have a division of labor where they're data scientists, but then they're ML engineers that do a lot of that pipeline, you know, fitting. And then there are ML ops people that build monitoring tools and are constantly managing, monitoring, maintaining, because that model has to be up 24/7 whenever people are using it, or it needs to be running in the background, right? So I think there is a huge IT component to doing this successfully. And I think there's a huge data engineering component to it. And there has to be that 3-part team, the scientists, the data people, and the IT people that do the software and the systems and the cloud instances and things. But it's not for lack of technology. It's really getting those 3 teams to work really closely together to deliver a production solution. But it's not inexpensive and it's not fast, unfortunately.
Yeah. Yeah, I think I saw in your book you had on one of the pieces around like silos, right, with like the IT team supporting kind of like an initial like MVP for a model with the data science team, right? Like they might have to allocate, like you end up in their backlog, right? And they have to allocate resources to make you successful, right, as a data science team. And in reality, if you just had kind of a sandbox environment, like, or a pre-prod, like, if we want to call it that type environment for your modeling that you could control, to Karla's point, right? Like it kind of unlocks a lot of capability for decision and data science teams, right? Like, and I think that's kind of what you've described in the past to me, Doug, with what you all have at Walmart.
Yeah, I'm a big fan of MVP and ready, fire, aim, and moving very fast, iterative, interactive test and development cycles. That gets you to the point where once the model's working, then you need to put it into production. Now,
Production, yeah.
there are some times when it's a one-time decision, and you may very well build a model, get the answer, and then you're done. But more often than not, if you're going to be doing forecasting to figure out how many tractor trailers do we need at Walmart every week, well,
Yep.
that's going to go on indefinitely, and that has to be a
Yeah.
stable, ongoing system. But yeah, we build everything as microservices, right? So contract programming, you give me these inputs, I give you these outputs, and there are two prongs on our microservice that plug in to the whole ecosystem of many, many other systems at Walmart. And that engineering team then has to take our model and plug it in to their GUI or their database or their system. And that can result in maybe waiting a bit, until
Yep.
their backlog catches up.
Yeah, for sure. Yeah, I
Yeah, I
think
feel like
that
with any of these models that sort of live in perpetuity, it's like once you get the model out there, it's like congratulations, now you get to spend all of your time researching why it did what it did. Right?
and maintaining it. Yep.
Yeah.
And yeah, and I think maintenance is something that maybe we don't talk about enough either with like kind of the transition from academia to industry too. It's like once you've created that artifact, like your team is now responsible for that decision, right? That piece of code is now your responsibility, right? So maintaining it over time, observing what it's doing over time, right? All of that infrastructure needs to be in place for you to do that job successfully to get to all the outcomes we just talked about, right? I think Carly, so you started that project at the SEC for like 6 months, right? And then it iterated how many times, from there. So awesome. Well, I think we're about at time. So I think Haley's going to hop back on here. Maybe if there are any questions that we could take, and then we'll wrap up for the day.
So I am going to walk through a couple of closing notes, but I think final question for Karla and Doug would be if you could go back in time and communicate with your former selves, your earlier selves, what piece or pieces of advice would you give yourself, knowing what you know now, as far as being a successful practitioner in the decision intelligence and decision science space? Maybe Karla, we start with you. And if you want, you can punt to Doug and then go back and forth.
Well, I thought at the beginning that you built a model and you handed it to somebody and you walked out. Absolutely wrong. I would say expect things to go wrong. Look, I mean, things going wrong tell you how an organization works and what it really needs. So rather than hearing, this is what we need, and oh, good, it's an optimization model, and maybe we'll have a little simulation to confirm what we think is going on, spend a lot of time listening and a lot less time modeling, and you'll probably be more successful.
Yeah, I hate to use cliches, but that old saw of you have two ears and one mouth, use them proportionately. That applies so well in this context that when you're early in a project, when the only talking you should be doing as the analytical person is asking questions and then shutting up and listening and taking notes. And, the first project that I ever did that I was responsible for, lock, stock, and barrel, the model, the coding, the project management, the business analyst, I remember filling up a couple legal pads of notes, just listening and understanding what they were doing, right? Um, and the thing I would tell myself is the lessons that I've learned got, an MBA that taught me about how business really works. And they're usually financially driven decisions. And you've got to speak, as Karla said, in the language of whomever you're speaking to, and really, tailoring the conversation to the metrics that they care about. And then that human side, the change management aspect. And that was one of the motivations to write the book. Even though it's number 5 on the list of the top 10 reasons projects fail, it could be they all could be number 1, but that one in particular. People talk about, I got my master's at Georgia Tech in OR, and I did 48 credits in 1 calendar year. So people talk about surviving that, right? I thought it can't get any worse than that when I walked out the door and went to American Airlines. That's got to be the hardest thing that I'm going to encounter. And, the real world made that look like a cakewalk. That made it look like vacation. So understanding the human dimension that you're dealing with people because I came out of school thinking it's all about the math, it's all about computers and coding and models and things. And those are just like stepping stones. But until you get somebody to say, I want to use this thing and it generates value, it's just homework. It's like a math problem up until that point. And those are the two big lessons, really understanding the business problem and the business impact and understanding the human dimension. If you do those two things and you're also really good at the math, you'll be inordinately successful.
Apologies, I was muted. I was saying, and maybe bring back legal pads. Excellent. So we are going to wrap today. Couple items just for folks to be aware of, things that are coming ahead. Advent of OR is happening right now through the Feasible newsletter. You can follow it on LinkedIn. We can share some links to that. It will conclude at the end of the month. We have more Decision Fest happening tomorrow. So we can share more links around that. We hope that folks tune in. There's two community events that are happening next week on Friday. One through Optimization for All, which is a little bit more European time zone oriented, and then one through Informs. It's a little bit more North America, South America time zone oriented. Two conferences to be aware of in April, in-person conferences, one through Informs, their Analytics Plus conference, and then also the Euro Practitioners Forum annual conference that's happening in April as well. So with that, Ryan, Carolyn, Doug, Karla, thank you very much for your time today and for the conversation. Thank you everybody for joining, and we'll see you next time.
Thank you.
Thanks all.
Thank you all.
You.